Hey guys, so welcome back. Today we're going to talk about part 3 of AC motor controls. Today, today's subject is going to be primary resistor type starters. We're going to talk about why reduced current starting is important, describe the construction and operation of the primary resistor starters. We're going to talk about how to read the draw diagrams for primary resistor starters. We're going to talk about how to connect squirrel cage motors to primary resistor starters. Then we're going to talk a little bit about how to troubleshoot electrical problems on the primary resistor starters. So what is a primary resistor type starter? A simple and common method of starting a motor at reduced voltage is used in primary resistor type starters. In this method, a resistor is connected in series in the lines to the motor. Thus, there is a voltage drop across the resistor and the voltage is reduced at the motor terminals. Reduced motor starting speed and current are the result. As the motor accelerates, the current through the resistor decreases, reducing the voltage drop and increasing the voltage across the motor terminals. A smooth acceleration is obtained with gradually increasing torque and voltage. The resistance is disconnected when the motor reaches a certain speed. The motor is then connected to run on full line voltage. The introduction and removal of resistance in the motor starting circuit may be accomplished manually or automatically. Primary resistor starters are used to start squirrel cage motors in situations where limited torque is required to prevent damage to driven machinery. These starters are also used with limited current in rush to prevent excessive power line disturbances. It is desirable to limit the starting current if the following cases apply. When the power system does not have the capacity for full voltage starting. Second, when full voltage starting may cause serious line disturbances such as in lighting circuits, electronics, simultaneously starting of many motors, or the motor is distant from the incoming power supply. In these situations, reduced voltage starters may be recommended for motors with ratings as small as 5 horsepower. Reduced voltage starting must be used for driving machinery that must not be subjected to a sudden high starting torque and the shock of sudden acceleration. Among typical applications are those where belt drives may slip or where large gears, fan blades, or couplings may be damaged by sudden starts. Automatic primary resistor starters may use one or more than one step of acceleration. Depending upon the size of the motor being controlled, these starters provide smooth acceleration without the line current surges normally experienced by the switching autotransformer type of reduced voltage starters. Primary resistor starters provide close transition starting. This means The motor is never disconnected from the line from the moment it is first connected until the motor is operating at full line voltage. This feature may be important in wiring systems sensitive to voltage changes. Primary resistor starters do consume energy, with the energy being dissipated as heat. However, the motor starts at a much higher power factor than with other starting methods. Special starters are required for very high inertia loads with long acceleration periods, or where power companies require that current surges may be limited to specific increments at stated intervals. Next is Primary Resistor Type Reduced Voltage Starter. In the image above, a primary resistor type reduced voltage starter shows the starter with 2 points of acceleration connected to a 3-phase squirrel cage induction motor. When the start button is pressed, a complete circuit is established from L1 through the stop button, start button, and coil M, and the overload relays contacts to L2. When coil M is energized, the main power contacts, or M, and the control circuit maintaining contacts, M, are closed. The motor is energized through the overload heaters and the starting resistors. Because the resistors are connected in series with the motor terminals, a voltage drops occurs in the resistors and the motor starts on reduced voltage. As the motor accelerates, the voltage drop across the resistors decreases gradually because of the reduction in the starting current. At the same time, the motor terminal voltage increases. After a predetermined acceleration time, the lane contacts M closes the circuit to the contactor coil S. Coil S in turn closes contacts S. The resistances are shunted out, and the motor is connected across the full line voltage. Notice that the stop button controls coil M directly. When the main power contacts M open, coil S drops out. After coil M is energized, a pneumatic timing unit attached to the starting unit M delays the closing of time contact M. This scheme uses start M for a dual purpose and eliminates one coil. A timing relay additional control contacts S connecting in parallel to the on delay contact M provides additional electrical security to ensure coil S normally opens and it is maintained. For maximum operating efficiency, push buttons or other pilot devices are usually mounted on the driven machinery within ease of reach of the operator. The starter is located near the motor to keep the heavy power circuit wiring as short as possible. Only 2 or 3 small connector wires are necessary for the starter and pilot device. A motor can be operated from any several remote locations if a number of push buttons or pilot switches are used when one magnetic starter, such as a conveyor system. AC primary resistor starters are available for use on a single-phase and three-phase reversing operations. They are also available with multiple points of acceleration. 4-point resistor starter. The following image illustrates a 4-point resistor starter. Operating start button energizes contactor S1, connecting the motor to the line. The total resistance is in each line. The mechanically operated timer S1 closes to energized contactor S2. The closing of contacts S2 shunts out a portion of the starting resistor. The mechanically operated timer S2 closes to energize contactor S3. The closing contacts S3 shunts out additional resistance in the resistor bank. The timer S3 closes to energize contactor M. The closing of contacts M connects the motor at full voltage. An electrical interlock on M then opens the dropout contactors S1, S2, and S3. The rotor may not start turning until the second or third point, but reduced voltage will have been accomplished. The timers or timing relays used are of the preset time type, such as pneumatic, dashpot, or solid-state timers. Compensating type current relays are also used. In the next image, you'll be able to see a resistor or bank resistors used to start small motors. These resistors consist of resistance wire wound around porcelain bases and embedded in refractory cement. A primary resistance type starter has the following features: simple construction, low initial cost, low maintenance, smooth acceleration in operations, continuous connection of the motor to the line during the starting period, a high power factor. These starters should not be used for starting very heavy loads. Because of their low starting torque, these starters are said to have low starting economy because the starting resistors dissipate the electrical energy. Terminal connections are made at a marked terminal block. Thank you guys for watching, and that concludes the resistor type starting method. Again, thank you so much for watching. Thank you to all my subscribers, new and old. And again, please like, share, and subscribe. See you in the next one.